When we imagine the Earth millions of years ago, it's inevitable to think of dinosaurs, right? Yes, those large reptiles are impressive, but life on Earth began long before they appeared. In those early times, everything was very different from what we know today, even different for the dinosaurs. Let's discover together the incredible journey from the early days of Earth until the dinosaurs appeared. Like in every story, it's best to start from the beginning. About 4.6 billion years ago, the dust and gas that remained after the sun formed began to come together, creating enormous rocks in space. These rocks, which could be hundreds of kilometers in size, collided repeatedly until little by little they joined to form our planet. However, the Earth back then was nothing like the one we know today. It was a very dangerous place, with seas of lava, high levels of radiation, and frequent asteroid impacts, an extreme environment that lasted for a long time. It wasn't until about 3.7 billion years ago, nearly a billion years after its formation, that the Earth cooled enough to start resembling what we know today, reaching temperatures similar to those we experience now. This is where the story becomes truly interesting. However, that doesn't mean it was a place where life could exist. It was composed mostly of water and had an atmosphere almost devoid of oxygen. It was a world with turbulent seas and many rocks. The only sound you would hear was the constant crashing of waves against the shore. Additionally, there were some volcanic eruptions. Yes, it sounds terrifying, but deep in the waters of this dark place, something incredible and surprising happened. Life was born. We don't know exactly how, but a special combination of processes and elements in Earth's oceans made it possible for very simple, single-celled organisms to appear, and some of them began to produce oxygen. For billions of years, these small, unicellular beings were able to live freely, taking in nutrients and releasing their own waste. Such simple life, but little by little, they began to change and become more complex. This reached a crucial moment at the beginning of the Cambrian period, about 538 million years ago. Before the Cambrian, Earth's land had formed a large continent called Rhodesia. However, when the Cambrian began, Rhodesia split into several smaller landmasses, the largest being the continent Gondwana in the southeast. But that's not the most exciting part. Let me introduce you to the Cambrian explosion, the event with the greatest increase in life, diversity in the history of our blue planet. When I say explosion, I'm not referring to a large fireburst. This explosion means that many new creatures appeared. Until then, only single-celled beings existed. Now, more complex life began to develop. Most of the basic life forms we know today first appeared during this time. Relatives of crabs, mollusks, starfish, and worms began living underwater. Don't get me wrong, this explosion occurred over tens of millions of years. But considering the little evolution of the previous billions of years, it was a very important event. Scientists are still not in agreement about what caused the Cambrian explosion. Do you remember I mentioned that some of those simple organisms began to produce oxygen? Well, one theory is that these organisms grew very rapidly, greatly increasing oxygen levels and allowing new, more complex life forms to emerge. These new life forms took advantage of the simpler ones and began an evolutionary race that would define the development of life on Earth forever. No matter how it happened, Earth was now ideal for these new life forms. The average temperature was much hotter than before, and probably the waters were around 43 degrees Celsius. This, along with more oxygen and carbon dioxide, gave life the opportunity to evolve, and so it did. Eyes, limbs, mouths, exoskeletons, shells, all of these features began during this time. However, many of the animals that had these enhancements still looked very strange, such as trilobites. These arthropods, with terrifying-looking shells, suddenly appeared throughout the ocean, eating plankton, scavenging for food in the debris and hunting other animals. You might recognize them by the large number of fossils that still exist today. In fact, trilobites were some of the most successful animals that ever existed and lived for hundreds of millions of years. But they weren't the only beings to appear during the Cambrian period. The first fish also emerged. They started as slimy, jawless animals that resembled eels. This marks the moment when the first true vertebrates evolved. It's not that they were very impressive at first. Unanozoon was a strange, worm-like species that had a spine, although it seemed to have no bones. Other Cambrian animals were even weirder, like Pavinia, a deep-sea species that looks like it was drawn by a child after drinking some beers. Pavinia used its long beak to scoop up small prey and bring them directly to its mouth, something that would be useful for devouring Pringles potato chips. But as the relationship between predators and prey was established, one animal had to stand out or swim better than the others. This animal was Anomalocaris, which means strange shrimp, and it was the top predator of its time. It measured just over 30 centimeters long, which was large for that era. This fearsome shrimp roamed the oceans, eating soft animals like worms. With such a strong predator lurking, animals had to adapt even more to survive. Evolution sped up a bit, or at least that's how it should have happened. You see, about 485 million years ago, just when it seemed like everything was improving and life was steadily advancing, a disaster occurred. We still don't know exactly why, but it appears that volcanic activity caused a mass extinction event. However, not everything was destroyed. Some creatures, like our friends the trilobites, continued to thrive, but the event was definitely of a large magnitude. The Cambrian period officially ended, and a new period was about to begin. The Ordovician is primarily known for a major event called the Ordovician biodiversification, also known by its English acronym GBE. For about 30 million years, the continent shifted, sea levels dropped, and the oxygen in the oceans began to rise again. The moving continents formed new islands, creating separated habitats in the waters that now had more oxygen. These new places were perfect for life to expand and grow. The first fish continued to evolve, becoming more like the fish we know today, although they still had a long way to go to resemble modern fish. Elsewhere, more terrifying creatures appeared. Let me introduce you to Eurypterids, or sea scorpions. Does that name scare you? These predatory arthropods weren't true scorpions, but they are called that because they had long tails with spikes, claws, and looked very dangerous. For example, the first of their kind, called could measure over 1.5 meters, which is truly impressive. It's a good thing these creatures went extinct a long time ago. Although they were very fearsome, they weren't the largest predators. That title belonged to the Camarasarosa animals similar to modern octopuses and squids. Camarasaros could reach up to 7 meters with their shells and swam in the depths, hunting arthropods, like sea scorpions, to eat. Yes, the sharp beak of the Camarasaros was strong enough to pierce through the hard exoskeletons and shells of their prey, making them the bosses of a world full of small animals. But it wasn't just the animals that were changing. Plants were also about to dominate the world. Primitive algae had existed in the seas since the Cambrian, but they weren't very important until the Ordovician changed everything, and algae began to grow much more. Algae evolved and spread onto land for the first time in the form of moss, while a species that lived on dry land. These first migrants had no roots or other specialized parts to retain water on their own, so they lived near bodies of water where there was moisture. However, despite starting modestly, this was the beginning of nature conquering the earth. Plants began to absorb carbon dioxide from the air and release oxygen, which would eventually lead to the creation of more complex life forms. The Ordovician period ended about 443 million years ago with another great extinction, this time caused by an ice age. No, this time it was due to an ice age. In fact, there have been several throughout the history of our planet. Each has been very destructive, and this was no exception. Starting 460 million years ago, and for the next 40 million years, glaciers covered the southern hemisphere, cooling the whole world and severely affecting marine animals everywhere. Although all major groups of animals survived, their numbers decreased greatly, and many important species, such as the Camarasaurus, did not manage to survive. In fact, around 80% of all marine animal species disappeared. Surprising, right? Interestingly, some scientists say that this tragedy was caused by the success of the new land plants. They say that moss absorbed so much carbon dioxide from the air that it cooled the planet, ultimately causing a great ice age. Whatever the case, one thing is certain: the Ordovician period ended and the Silurian period began. 40 million years later, the ice finally melted when the carbon dioxide returned to the atmosphere. The melting of the ice caused sea levels to rise and the climate to stabilize, allowing life to expand once again. With the disappearance of the Camarasaurus, sea scorpions were able to become the top predators. They developed more than ever, diversified, and became even more fearsome. Carcinosoma, a type of very large sea scorpion, grew to over 2 meters in length. Wow! Fish also continued to adapt. The first fish with movable jaws appeared in the Silurian period. Additionally, the first coral reefs emerged. These reefs became important parts of new ecosystems and were home to resilient trilobites and other creatures. Meanwhile, land plants were strengthening. Plants began to take on more complex and recognizable forms, evolving stems that could absorb and retain water on their own. These plants became the foundation of all modern flora and helped increase the oxygen in Earth's atmosphere. This time, instead of causing an ice age, the increase in oxygen allowed animal life to thrive on Earth. Arthropods began to leave the oceans. The first groups were probably myriapods, like centipedes and millipedes, arachnids, and also scorpions. Initially, these animals might have only ventured out of the water to escape predators or seek new food sources, but the idea of a completely new environment was very appealing. Life in the ocean was highly competitive, but the Earth offered many new opportunities. It's not that every species that tried to come out lost its gills immediately and learned to breathe air. Scorpions from the Silurian period still had gills, and although they reached land, they had to keep them moist to breathe, so they didn't stray far from the water at first. The Silurian period ended about 419 million years ago, with some minor extinction events likely caused by climate changes. I say they were relatively minor because, unlike other events, they did not destroy all life on Earth, nor put the planet at risk of losing all life again, although they were not pleasant. After this, the Devonian period arrived, which would be the most important period for life since the... To begin with, the first known sharks evolved, although they were not the main predators we know today. In fact, they were surpassed by a group of bony fish called placoderms, such as a large creature named Dunkleosteus was the top predator of its time. At its smaller size, it was a little shorter than a large male great white shark. That's 3 times the size of an adult person. But at its largest, it measured around 8 meters, similar to several great white sharks combined. Undoubtedly, this was the largest species living at that time, and one of the most fearsome fish that ever existed. Its large head had guillotine-like teeth, and experts say its bite was stronger than that of a saltwater crocodile. To give you an idea, saltwater crocodiles have the most powerful bite of any living animal, but Dunkleosteus had more than doubled the strength. Just look at its jaw. Moreover, fish were not the only ones growing in size. On land, plants also began to grow. As a result of all the previous evolution, the first large trees with complex root systems, branches, and height appeared. These trees formed the first forests, which produced a lot of oxygen for the air, while simultaneously absorbing large amounts of carbon dioxide. All of this made the terrestrial ecosystem even more attractive for new life, and thus vertebrates began to notice this change. You see, some species of fish, like lungfish, spent more and more time in shallow waters, and some even ventured onto land for short periods. But in the Devonian, everything changed. Animals evolved. A very interesting example of this is the tictaholic, the first known vertebrate that could breathe out of water. This animal had characteristics of fish, amphibians, and reptiles, being a mix between living on land and in the sea. Although it still lived primarily in water, it could go onto land when necessary. Then we have Lithiortaga, one of the first tetrapods animals with 4 complete legs like us. Although they also spent most of their time in water, the world was never the same again. Meanwhile, arthropods that lived on land began to diversify, developing and spreading wingless insects and spiders. However, for the creatures that still lived in the sea, things were about to get much worse. As the Devonian period came to an end, oxygen levels in the oceans began to drop drastically. Without enough oxygen, large groups of marine creatures went extinct. Trilobites and sea scorpions died, and although some survived, they never became as numerous again. On the other hand, dominant species like dunk were completely eliminated, and up to 70% of all invertebrate species went extinct. We don't know exactly what caused the sudden drop in oxygen, but scientists think it was probably due to the trees. Listen, the trees of this time grew up to 40 meters tall, so they needed deep root systems to support themselves. The roots not only kept the plants in place and absorbed nutrients, but they also changed the surrounding soil by breaking rocks and creating nutrient-rich earth. The problem: this soil spread across the entire planet, and much of it was washed into rivers and oceans, carrying all the nutrients with it. This caused a great growth of algae in the water. and as these new algae performed photosynthesis, they used up all the oxygen in the water. This was very bad for the species living there. Wow! Who would have imagined that plants could cause so many deaths? If you were around during that time, you would take great care of your plants. However, although life in the water was largely destroyed, land beings continued to grow and prosper, changing the balance of power. Next came the Carboniferous period, which showcased the great control that life on Earth had achieved. About 359 million years ago, during the Carboniferous, plant life on land flourished and multiplied, creating vast forests and swamps that covered almost the entire planet. This enormous amount of plants caused the oxygen in the air to rise to unprecedented levels, and this had surprising effects on the animals of the time. Do you remember the arthropods that first arrived on land during this? By then, they had had plenty of time to evolve and adapt, and they were everywhere. When the oxygen in the air increased significantly, these arthropods evolved even further. Arthropods obtained oxygen through small openings in their body. With more oxygen available and many new plants as food, arthropods grew to enormous sizes. For example, the heart of Pleura, which was the size of a car, seriously, it could reach about 2.5 meters. Fortunately, for the small insects of the time, millipedes had always been vegetarians. Back then, millipedes were always vegetarians. Not many creatures were small, even those that flew. The so-called Meganura was one of the largest flying insects that ever existed, with a wingspan of 76 centimeters. That's almost the size of an American crow. Tetrapods also increased greatly in diversity, both on land and in water. The first amphibian Diplocaris appeared during this time and was a rare species. This 90-centimeter monster had a strange boomerang-shaped head that, according to experts, helped it glide through the water or fend off predators. It would be difficult for anything to eat this animal, but it was on land where the tetrapods took their next great step. You see, no matter how much time they had spent on land, they still had to return to the water to reproduce. That changed when an incredible adaptation evolved. Land tetrapods began to lay eggs with hard shells. These new eggs could keep the amniotic fluid inside, so they no longer needed to lay them directly in the water, and the shells protected the offspring from predators. With this, tetrapods were able to live on land for the first time. These were the first amniotes, the ancestors of most modern land animals. Additionally, we are only a few 100 million years away from the first egg. It was lucky that tetrapods developed this adaptation when they did, because the end of the Carboniferous would completely change the planet. Once again, you see, the different parts of Earth had been gradually changing over millions of years. About 335 million years ago, all the continents came together to form a supercontinent called Pangaea. But what did this mean for life on Earth? Well, the vast tropical jungles that covered the planet suddenly faced problems. They split and dispersed, and as Pangaea formed, the trees that previously had plenty of water nearby were now inland and dried up quickly. This destroyed many habitats, and as a result, oxygen levels in the air dropped significantly. Additionally, temperatures decreased, and a great ice age was approaching, which wiped out the tropical jungles. The formation of Pangaea initiated a series of changes that caused the collapse of the Carboniferous period about 299 million years ago. After this, the world became much drier with fewer forests, very different from how it was before. Many species went extinct due to these major climate changes, including 2 types of giant arthropods that required a lot of oxygen. But amniotes, animals that lay eggs with hard shells, thrived because they didn't need to return to water to reproduce, and had scaly bodies that prevented water loss. This set the stage for them to conquer the Earth. Amniotes split into 2 groups, which would be the ancestors of mammals, and sauropsids, which would evolve into reptiles and birds. Both groups began to come together and dominate. Then came the Permian period, which started with a rise in temperature. The glaciers that formed at the end of the previous period began to slowly melt, and most of the interior of Pangaea turned into dry deserts. The supercontinent heated up further as the period progressed, making life difficult. The animals that were best at conserving water were the ones that thrived. This is where synapsids and sauropsids come in. These groups diversified and spread across Pangaea, becoming the dominant land animals. But it was the synapsids that truly ruled during the Permian. They were slowly evolving and increasingly resembled mammals. An example of these synapsids is the metronome, a large and fearsome creature, often mistaken for a dinosaur. In reality, it is more closely related to mammals. It was the main predator at the beginning of the Permian and could grow up to 4.5 meters long, making it quite impressive. It would be hard not to be the best when you're as big as a sports car, although no one is entirely sure what that part of its back was used for. Some scientists say it helped regulate body temperature, while others believe it was used to attract mates. Personally, I like to think it was a practical place to hang Christmas ornaments. Despite being very successful, Dimetrodon eventually went extinct after living for 16 million years. After Dimetrodon, another group of synapsids, the Gorgonopsians, took control in the late Middle Permian. No, they're not the villains from Star Trek, and they weren't as large as Dimetrodon. The largest species, Linos transibia, measured only 3 meters long, but they were very dangerous. Gorgonopsians had mouths full of 15-centimeter long, saber-shaped teeth, likely used to slice through the skin of their prey. That's extremely terrifying, and these teeth faced off against animals, like the heavy cerapsids, which were slow, protected herbivores that had to walk kilometers to find food. But enough about the Permian era also gave rise to the largest animal that ever existed. Are you ready? Well, let me introduce you to Catil. Just look at its little head. That guy has no neck. What a tiny and adorable plant-eating monster. But don't get too attached to it. Remember when I said the Permian was going to get hotter? I meant it. Over millions of years, a series of massive volcanic eruptions began to devastate what is now Siberia. These eruptions spread enormous amounts of hot lava all over the planet. I'm talking about lava ferns, the size of half the United States, releasing huge amounts of carbon dioxide into the atmosphere. All this carbon dioxide trapped heat in the atmosphere, drastically raising the Earth's temperature and forcing animals to adapt or die. Marine animals fared no better than land animals. The ocean absorbed some of the carbon dioxide, causing the water to become dangerously acidic. Then the higher temperatures caused wildfires on land, burning the remaining plants, destroying forests, and exposing previously hidden rocks. These rocks eroded rapidly, and the nutrients left behind were washed into the ocean, inadvertently triggering an explosion of life. So everything changed, right? Well, not exactly. In reality, the vast number of new life forms was more bad news than good. They consumed the little oxygen that remained in the sea, suffocating any creature that had survived the initial onslaught. Wow! By the end of the Permian, about 251 million years ago, this terrible event reached its peak, known as the Great Dying. It was the most devastating mass extinction ever, bringing life close to complete annihilation. An astonishing 70% of terrestrial animals and 90% of marine creatures were wiped out. The few creatures that survived became extremely scarce on the planet. All the prehistoric periods we've seen so far belong to an era called the Paleozoic, which means ancient life. Life continued, leading to the Mesozoic era, the age that would eventually bring dinosaurs, but not yet. The Mesozoic era began quietly with the Triassic period. During the first 5 million years, life slowly recovered, allowing new dominant species to emerge. This new world was very challenging to live in, and only the hardiest species could survive. Unfortunately, most synapsids could not adapt and were completely wiped out by the Great Dying. Although some survived and eventually evolved into modern mammals, they weren't the main players for long. On the other hand, sauropsids adapted very well, thanks to their ability to live outside water with their hard-shelled eggs and moisture-retaining scales. They not only recovered, but came to dominate the planet. In fact, during the Triassic, sauropsids diversified and evolved very rapidly. Some moved into the empty oceans and evolved into the first marine reptiles, like strange and fearsome fish-like creatures that hunted using some of the largest eyes in the animal kingdom. Alongside them, plesiosaurs also controlled the seeds. These equally strange creatures had very long necks that helped them hunt more stealthily. Both marine reptiles thrived for hundreds of millions of years. Other creatures, like the unusual Drepanosaurus, evolved to live in trees, perhaps acting like modern lemurs and sloths, hanging from their tails. Like a lemur, the Drepanosaurus had a very long claw for searching for insects in nests on tree branches. So, basically, it was like a lizard with a monkey's tail. But trees weren't the last challenge for these newly evolved reptiles. Some began to evolve to fly. For example, they experimented with strange designs like cherry-book. Unlike most flying animals we know, this small reptile had wings on its hind legs rather than its front legs. Because of this, it actually couldn't fly. It could only manage a sort of clumsy flight. As expected, this design did not survive to the present day. However, by the end of the Triassic, this trait evolved and improved in pterosaurs. Hollow, air-filled bones made these flying reptiles light enough to soar. Their wings extended from their forearms across their bodies and down to their ankles. In other words, these small flying reptiles surpassed cherry-bomb. But now that we've talked about the sea and sky, let's discuss what was happening on land. Well, with synapsids nearly completely extinct, sauropsids evolved and became a new subclass called archosaurs, taking the place of synapsids, and they were very successful. You see, archosaurs had a very efficient respiratory system that allowed them to survive in harsher conditions. The oxygen in the air was likely limited during the Triassic, due to the high levels of carbon dioxide in the atmosphere following the Great Dying. This excellent respiratory system enabled archosaurs to thrive where other species could not. But that's not all. Archosaurs also quickly developed upright limbs. It may seem strange, but this gave them a significant advantage. You see, tetrapods with limbs extending outwards like modern lizards moved by flexing their bodies side to side. This directed dirty air from one lung to the other, instead of expelling it to make room for fresh air, preventing them from breathing and walking at the same time. But with their upright legs, this was no longer a problem for us. One particularly formidable member of the group was Pulse. This husked animal resembled a mix between a T-Rex and a crocodile, a very terrifying combination that made other creatures fearful. Experts believe that Postosuchus hunted its prey by walking on all fours, but when it got close enough, it would rise on two legs to bite the neck or back of its prey. In fact, it was so dangerous that when dinosaurs appeared, Postosuchus was still a strong predator. The archosaurs took over the world, but in the middle of the Triassic, something else happened that changed everything on the planet. There, in the open lands, some types of archosaurs that looked normal appeared. However, they were not, as these were the first dinosaurs, with all the advantages of their relatives and a remarkable ability to reproduce quickly. They were ready to dominate the world and begin a new era. Click on the video on the screen to continue learning more with us. See you in the next video.